Su-budoo arrived at the construction site under a big bridge. An operator with a radio-controlled device was there waiting for him.
Su-budoo, great to see you again. Let's get to work.
Su-budoo revved his engine powerfully and moved forward, then went straight into the river.
I'm an amphibious bulldozer that can move around and do construction work on land, in the ocean, and in rivers. I feel proud and full of energy when I know that I'm the only one that can do this work.
The caissons that form the foundation of the bridge's piers, built across the Natori River in Miyagi Prefecture, were exposed in the giant tsunami during the Great East Japan earthquake. The bridge formed a strategic link north to south between Sendai Airport and Sendai Port, so it needed to be reconstructed as quickly as possible. However, the high flow velocity of the river, water depth, and overhead space restrictions made it difficult for work vessels to start construction. So SUIBULL, which had been waiting patiently and biding its time, was singled out to complete the job. SUIBULL were used extensively for construction work in the 1970s. However, the group of 17 SUIBULL was scaled down to 5 as demand for this kind of work decreased and the bulldozers aged, waiting in Asanaro Aoki Construction's warehouse for their time to come. The Great East Japan earthquake shook the Tohoku region in 2011. The Yuriage Bridge, spanning the mouth of the Natori River, which flows through Miyagi Prefecture, was damaged by the massive tsunami that followed. We couldn't use the usual work vessels because of the fast-flowing river and widely scattered debris around the Yuriage Bridge. During the struggle, we were inspired to bring back our trusty SUIBULL to save the day.
Wait a minute, we have Su-budoo.
SUIBULL were put into operation in 1968 by Komatsu Limited for use at sites where work vessels and land-based machinery could not be used to perform construction work. Our group company was involved in the development of these amphibious bulldozers at that time, right from the beginning. SUIBULL was first used for emergency repair work on the Toyama Bridge over the Jinzu River, essentially positioning this as Japan's very first unmanned construction project.
I want to take a moment and tell you a little bit about myself. I'm about 9.3 meters long, 4 meters wide, and weigh 43.5 tons on land. My rear section is equipped with a hydraulic ripper to crush bedrock. The 9.8 meter high duct, which prevents the engine from being flooded, is equipped with a wireless antenna and an air intake and exhaust tower. SUIBULL are internally pressurized, so they do not take on water when submerged and can work underwater at depths of up to 7 meters. The width of the crawlers has been increased to 710 millimeters to reduce ground pressure. SUIBULL are not simply watertight versions of regular bulldozers. We have been equipped with a variety of innovative means to work underwater. This dozer with a hydraulic apron is ingenious for excavating underwater. Sediment is removed using the cutting edge of the soil removal blade. The bucket-shaped apron apparatus attached to the large soil removal plate is used to hold and haul away sediment to prevent it from scattering into the water. Naturally, every possible measure has been put into place to ensure safety. The engine room, warning lights, bilge pumps, and diver controls create a safe working environment at all times. You can see how unique Su-budoo is when compared to its rivals. We can work in depths of up to 7 meters. Some work vessels can work in depths of up to 100 meters. However, we work in depths of up to 7 meters when it is inaccessible to larger work vessels. Work vessels require a temporary facility to dock themselves, but we can go straight into the water from land without using any such facilities. We're also not bothered by working in high-velocity currents, something work vessels are generally not good at. If water levels rise suddenly, Su-budoo can be evacuated quickly to a safe location using its own power. With general work vessels, there is a concern that mooring lines connected to the vessel may break and damage structures.
SUIBULL is piloted visually by operators with devices that use mature technology. With an effective range of 100 meters, radios may not be at the cutting edge, but the technology is far from out of date or behind the times. SUIBULL uses one of the most leading, trustworthy, and mature technologies in Japan, a source of great pride. SUIBULL has always proved worthy of our trust, delivering exactly what we expect. SUIBULL have been completely overhauled, cleaned up, and delivered to their new home here in Miyazaki. Even mature technologies need to continue to evolve to ensure that SUIBULL continue to make waves. While designed in the 1970s, SUIBULL continued to play a major role even today, filling gaps in cutting-edge technology. Today, we are working on the development of ICT to give fresh momentum to SUIBULL's uniquely successful performance. In bad weather or with construction sites that are located a distance away, it is difficult for operators to determine SUIBULL's exact height and position. Remote control based on the operator's line of sight is SUIBULL's greatest weakness. To bridge this issue, we developed ICT-based machine guidance excavation. Considerable skill is still required to operate SUIBULL today. ICT technologies are essential to the continuous process of improving productivity in the construction industry amid concerns about the aging construction workforce and lack of generations of youth willing to step into this role. AI may be the one running SUIBULL in the future.
Okay, SUIBULL. Great job today.
Thank you, operator. I was happy to see the look of satisfaction on everyone's faces at the site.
And SUIBULL swayed with pride.
I'm ready to do my best again tomorrow.